We are continuing in Unit 3 of our Precalculus course. In Section 3.6, we will look at the graphs of the sine and the cosine functions. And after we do the graphs and we identify the properties, we will discuss in our next video how to graph transformations of the sine and the cosine function. So if you remember, when we are on the unit circle, any particular rotation of theta on the circle has a point on the terminal side of the rotation, of the angle of rotation in the unit circle with coordinates cosine theta, comma, sine theta. So the vertical coordinate is where we measure the sine of the angle. And the vertical coordinate will be some number as this ray rotates, some number that at most will be when I am at the 90 degrees location, and it will be at most 1. And the lowest it will ever be is when this ray actually rotates and comes to the 270 degrees over here, and that will be at the smallest it will be -1. So let's see how that looks like. When we are graphing the sine function, the horizontal axis is the rotation. So this axis, that is the x-axis, is the rotation. The rotation will start at 0. And remember, 0 on this circle as a rotation is this location. Positive will be in the direction of counterclockwise, starting at 0 rotation, and a negative will be going clockwise. So 0 rotation is here, positive is in this direction, and a negative is in this direction. So if you can visualize the x-axis of our graph is actually the circumference of this circle. If it was infinitely long rotations, and I would just open up the circle into a straight line. And what we will measure on the y-axis, this y will be the value of sine of x. And the value of sine of x will be the value of the y-coordinate of a point on the terminal side of my rotation angle that is on the circle, the intersection of the terminal side and the circle. So when I am at 0 rotation here, the sine coordinate is equal to 0. And that means that 0 rotation and 0 sine, this point 0, 0 is a point on my graph. And then as I increase in the positive direction, my rotation, and I travel on the circle, the sine starts from 0 and increases as a positive quantity until I hit the rotation of pi over 2. And at that point, the sine is equal to 1. So when I go from 0 to in the positive direction here to pi over 2, my sine will increase, the function will be increasing until at pi over 2, I have a sine equal to 1. So my function will go kind of in that direction when I'm graphing it. But then when I pass pi over 2 in my rotation and I keep moving in the positive direction on the circle, my sine is still positive, but it decreases. And it decreases until I hit pi, in which case the sine at pi is equal to 0. So from pi halves to pi, let me make it kind of equidistant, my graph goes down because it decreases. So the way I'm going to graph this is I'm going to go up, increasing, and then I'm going to hit a maximum, and then I'm going to travel and I'm going to go down to 0 when my rotation is pi. So if I keep moving, remember the rotation is my point moving to the right all the time, right? That's the circumference of the circle unfolding on the positive x-axis here. If I pass pi, so if I keep going towards the positive direction, I will be now in quadrant 3 on the rotation of the circle, and my sign is now negative. And it will keep going down until I hit the rotation of 3 pi over 2 or 270 degrees, in which case, when the rotation point is at 3 pi over 2, I will have a sign equal to -1. And then after 3 pi over 2, my point that keeps going in the positive direction on the x-axis and in the positive rotation on the circle is now having a sign that increases but still stays negative until I hit 2 pi, and at 2 pi it will be 0. So it will be here. So the graph of the sine will go like that. And after that, I will be repeating myself. So I will be back in quadrant 1. I will be rotating on the circumference of this circle, and my sign will be positive. So this is my second rotation. When I hit 5 pi over 2, which is at the 90-degree location, I will have a sign equal to 1. And then I will keep going. I will be now in quadrant 2. When I hit 3 pi, I will be here, and my sign will be 0, etc., etc. And then I will cross over to negative signs, and then I will keep going. Now, if I go in the negative direction, let me see what I can erase here. So when I go in the negative direction, I start at 0 and I'm going this way. So again, this is the rotation on the circle, but I am now going in the negative direction. My sign is negative until I hit negative pi over 2. That will be -1. And then when I continue, my sign will be negative, but it will be increasing until I hit negative pi. That will be 0. So at negative pi over 2, I will be at -1, and then at negative pi, I will be at 0. So my graph will go like this. And then after negative pi, I will keep going in the negative direction, which is clockwise. My sign will become positive. When I hit here -3 pi over 2 rotation, I will be at 1. And when I keep going, my sign will be positive, but will be decreasing until I hit -2 pi, when my sign will be equal to 0. And then I will be repeating myself. After -2 pi, I will be in the quadrant 4. I will hit 0 when I go to -3 pi, and then I will start becoming positive, etc. So this is the graph of the sine function. And the graph of the sine function has a domain of all real numbers, because you can have infinitely long positive or negative rotation. It has a range between -1 and 1, inclusive, so closed brackets at -1 and 1, because these were possible values of the sine. And it was repeating every 2 pi. So every full circle rotation, I was coming back to where I started from. So this first rotation from 0 to 2 pi is called one cycle of the graph. And then this cycle of the graph actually repeats itself exactly every 2 pi. So it repeated itself this way every 2 pi, and then it repeated again beyond the negative 2 pi, beyond the positive 2 pi, etc. for every 2 pi. So it had a period of 2 pi, and it had a midline of y equal to 0. Y equal to 0 is the horizontal axis, x-axis. And if you paid attention, this was a symmetric wave. It was going up one, and then it was going down one, and then up one, and then down one. And the middle of that wave was y equal to 0. And then it has an amplitude equal to 1. And amplitude is the maximum distance from the midline. How high and how low do you go? And you go up one and down one. The amplitude in some problems in ohm is positive only, and I will want the amplitude in our tests to be answered as a positive quantity only. But there are some questions that specify a negative amplitude, especially if I start from the negative direction. Let's look at the graph of the cosine function. The cosine axis is the horizontal axis. So on this graph of the cosine, the y value will be the cosine coordinate of the point of rotation. The x-axis is the rotation. Let me see if I can get, there we are. All right, so this is x, and it will be your rotation. So again, I'm going to start from rotation 0, which will be here. And I'm going to go in the positive direction to begin with. So I'm going to go in this direction. When I am at 0, the cosine at 0 rotation is equal to the first coordinate of this point, which is 1. So actually, the first point on my graph will be this point. It will have rotation 0, and it will have cosine equal to 1, right? So every point that I will plot here will have rotation, comma, cosine. And my first point will be rotation 0 and cosine equal to 1. So what happens when I am in quadrant 1, starting at 0, I increase my rotation. So I move here on the circle, which on my graph is I'm moving to the right on the x-axis. And my cosine that starts at 1 is now decreasing until I hit rotation pi over 2, in which case my cosine is equal to 0. So there is a point, let's say here, pi over 2, where my cosine is equal to 0, so I'm right there. So the graph goes kind of like that. It drops, the cosine drops. When I pass pi over 2 and I keep going on the circle, this is the point of rotation. So now I'm in quadrant 2 here. My cosine has now become negative. And then when I hit rotation equal to pi, so if this point on the circle goes to pi, then my cosine, which is the first coordinate, will be equal to 1, negative 1. So at pi, I will have a point on my graph that will have rotation, pi, and cosine negative 1. So it's going to go like this. And then if I keep advancing after pi in the positive direction, so my point of rotation keeps moving here to the right, I will have negative cosine approaching 0 until I hit the rotation 3 pi over 2, and rotation 3 pi over 2 will have a cosine equal to 0. And then when I pass 3 pi over 2, which means I keep going here in quadrant 4, I'm right here, my cosine will be positive, and when I hit rotation 2 pi, I will have a cosine equal to 1. And then after that, I will repeat myself. I will be back in quadrant 1, decreasing to 0 until I hit 5 pi over 2. Then I will be negative until I hit 3 pi, and then I will be coming back up. I will be -1 here, and then I will be coming back up. Now, if I go in the negative direction, I will start with a cosine equal to 1 at 0, and then while I am in quadrant 4, so if I go in this direction, this way, when I hit negative pi over 2, my cosine will be equal to 0. And then I will have negative cosine if I keep moving in quadrant 3 until I hit negative pi. Negative pi will have a cosine equal to -1. So my cosine will be positive, but then after negative pi halves rotation, it will be -1. After I hit negative pi and I keep rotating in the negative direction, my cosine will be negative but increasing until rotation a -3 pi over 2, where I will have a cosine of equal to 0. And then if I keep going, I will be back in quadrant 1, where my cosine will be positive until I hit -2 pi, where the cosine will equal to 1. So here again in the that half of the circle, I will have a negative cosine in quadrant 2, and then in my last quarter of the rotation, I will be back in quadrant 1, and then I will keep going. I will repeat myself. I will be in quadrant 4, I will have positive cosine, then I will be in quadrant 3, I will have negative cosine, etc., etc. The wave is going to keep going. And again, we have one cycle of the cosine function. That cycle starts at 0 and goes to 2 pi. And this wave repeats for infinitely many cycles in both directions. And again, the domain is -infinity to infinity. The range is -1 to 1. The period is one full cycle of 2 pi. The midline is y equal to 0, and the amplitude is equal to 1. A function f is periodic if and only if there exists a real number p called the period of the function that has the property that for all x in the domain of f of x plus p is identical to f of x. And in the case of the sine and the cosine, that period p is 2 pi. 2 pi is 360 degrees. The period is always a positive quantity. A function with period p repeats its value in intervals of length p. These intervals are also called periods. And in your formula packet, you have the periodic functions here that basically state that this 2 pi and this 2 pi is the period for the sine and the cosine function, because k times 2 pi added to any rotation theta will land you exactly in the same place where you were, and you will have the same cosine and the same sine. So the sine function, one other thing that you have to remember is that the sine function is an odd function. Odd function means the sine of -x is minus the sine of x. And when you graphed that, it was symmetric with respect to the y-axis. It was symmetric with respect to the origin. So what happened here was, when I was graphing the sine function, any point on the graph had a symmetric with respect to the origin. Any point on the graph in quadrant 4 has a symmetric with respect to the origin. Any point in the graph in quadrant 2 had a symmetric in quadrant 4 with respect to the origin. And that had a opposite axis having opposite y's. One other thing about the sine function is that it has intercepts so it had intercepts at 0, at pi, at, let me see if I can move this graph. Okay, let me see. 0, pi, 2 pi, 3 pi, 4 pi, etc. in the negative direction, negative pi, negative 2 pi, negative 3 pi. So actually it has intercepts at k pi, comma 0. Right? So every time we have a multiple of pi, we get an x-intercept. The cosine function is actually an even function. That means that the cosine of negative x equals the cosine of x. And that gives us symmetry with respect to the y-axis. So if you take this graph and you fold it right at the y-axis, it's going to fall on itself. So I will have a point in quadrant 1 symmetric to the point in quadrant 2, and a point in quadrant 4 symmetric to a point in quadrant 3. So 3 and 4 are symmetric, and 1 and 2 are symmetric. It has intercepts at pi over 2, 3 pi over 2, 5 pi over 2. They were here. Negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. You can see the pattern I'm expecting at 7 pi halves, 9 pi halves, etc. So at odd multiples of pi halves. The way we write odd in algebra is 2k plus 1. So 2k plus 1 is an odd number for any integer k times pi over 2, comma 0. And if k is negative, then I will get negative values, negative odd multiples of pi over 2. In our notes, we have a note about how to use a graphing calculator. But in our class, for pre-calculus at our college, we do not allow graphing calculators. So for that, you can use a graphing utility to explore and when you study, but you have to understand how the algebra translates into a graph, because when you are taking a test, you are not allowed to use graphing utilities. In our next video, we will do transformations of the sine and the cosine function based on what we know from college algebra and graph transformations and what we learned for the graphs of sine and cosine in this section.